Have a good day. Wind load as per IS875 part 3. Still we have developed as per IS875 part 3 1987 code book. Now we are going to discuss about the wind load calculation as per IS875 part 3 in the year 2015. So actually it have revised in the year 2015. But as per your regulations, before your regulation have framed only IS 1987 have used. So till for examination purpose, they have followed only 1987. But if you do any project for your academic, or if you are going to do project in the industry, you have to follow only the revised code books. So IS875 part 3 have revised in the year 2015. So this only you have to use to find the wind load. And also if you do the analysis for seismic load, then you have to refer IS1893 2016 and all other codes, that is 875 part 1, part 2 and part 4 till we are following 1987 revised code only, but it have reaffirmed in the year 2018. And IS875 part 5 also have revised in the year 2015. So these three code books, if you are using for any work, you have to use only revised code books. So for that only this presentation. Here we are going to discuss only about 875 part 3 loads. So dead load we know this have not changed. Live load also have not changed. Only changes in part 3 2015 875. So here basic wind speed it have not changed, only class you have to refer 6.3, and the design wind speed have changed. Design wind speed you have to follow additionally K4 factor. So K4 factor is nothing but importance factor for cyclonic region. So how to find this factor and all will be discussed. One more changes is in the design. See here earlier design wind pressure PD equal to PZ, that is equal to 0.6 PZ square. But now it have revised. Design wind pressure have to calculate it by using the factor KD, KA, KC. And also design wind pressure should not be less than 0.7 PZ. If it is less than 0.7 PZ, then we have to take maximum of these two, either 0.7 PZ and PD. We have to calculate both. Whichever is maximum, we have to consider that for the design. And KD is nothing but the wind directionality factor, and KA area averaging factor, and KC combination factor. Now we'll discuss how to find these factors. Before that, the individual numbers, wind load on individual numbers, that equation also have not changed. The class 7.3.1 you have to refer external pressure coefficient minus internal pressure, and the external pressure internal pressure coefficients also have not changed on roof and wall. So only changes these factors, and the factors basic wind speed also have not changed. Earlier we had same, now also we have same basic wind speed for all the places. Probability factor K1, which will depend upon the life period, that also have not changed. Earlier also same tabulation, but K2 factor have changed now. Earlier we had terrain category and classes, 3 classes we had, but now we have only 4 terrain categories, but classes we don't have. See here, see this is for terrain category 1, 2, 3 and 4. But earlier we had terrain category 4 with 3 classes A, B, C. So this is the main change in the 2015 revised code book. And K3 factor have not changed. K3 as it is, if it is slope playing ground, then it will be 1. If it is in the hilly or cliff area, then we have to calculate by using appendix C. That and all have not changed. K4, that is important factor for cyclonic region. For industrial structures, we have to consider it is 1.15. And for cyclonic shelters or schools, communication, important buildings, it can be 1.3. And all other structures like residential buildings, we can take it as 1. K4 factor. And the wind directionality factor, this will be depends upon the shape of the building, and if it is a lattice structure, then it can be 0.9. Rectangular, triangular, square buildings, it will be 0.9. If it is a circular or nearly circular forms, then it can be taken as 1. Cyclone affected region also we have to take KD factor, that is directionality factor, as 1. So if our industrial building will be rectangular, so we can take 0.9. Area averaging factor, if the center to center distance area, if we calculate, that is tributary area, if that is less than 10, then it will be 1. 25, then it will be 0.9. If it is more than 100 or more than greater than or equal to 100, then we have to consider it as 0.8. So this is the area averaging factor from table 4. Next, combination factor. So this will be depend upon the clad building, internal pressure, external pressure, etc. For framed structure, we have to refer table 19. But for roof, sloped roof with internal pressure and external pressure, we can consider it as a 0.9. And external pressure coefficient, internal pressure coefficient, over walls, roofs, everything have not changed. Both are same. This also same, but only class have revised. It is 7.3.2. That's all. The values have not changed. Now we'll discuss a simple problem, how to find the wind pressure based on 875 part 3 2015. So same problem, to a 20 meter high building, 50-year life period, size of the building more than 50 meter, and the open terrain, category 1, wind pressure we have to find. So height of the building 20 meter, length of the building more than 50 meter, location of the building Delhi, open terrain, terrain category 1. These are all the given data. So with that we have to find. So first step we know we have to find the basic wind speed and factors. Here we have to find factors K1, K2, K3 and K4. See the basic wind speed for Delhi we know it is 47 meter per second, and risk coefficient it will be 1. Risk coefficient K1 for 47. 50 years life period, it is 1. And terrain category factor, now it is 20 meter high, terrain category 1, it is 1.12. And K3, we'll assume it is in the playing ground, so K3 1. And K4, cyclonic factor, our structure is industrial building, so it will be 1.15. See, K1 1. K2 1.12, K3 1 and K4 1.15. Next we have to find step 2, we have to find design wind speed. So design wind speed P is at now K1, K2, K3, K4 into VB, so that is 60.54. Next is step 3, we have to find design wind pressure. So that can be calculated. Wind pressure P is at 0.6 into VZ square, that is 2198.76. And the design wind pressure now PD equal to PZ, KD, KA, KC. So our building is a rectangular building. So KD directionality factor will be 0.9. And averaging factor, area averaging factor, in the problem it is given the length is more than 50 meter. Definitely width will be at least minimum 5 meter. If we take it as 5 into 50 will be 250 square meter. Definitely it will be more than 100 square meter. So we have to take KA as 0.8. Next, KC, combination factor. So subjected to both internal and external pressure. So we have to consider KC 0.9. KD 0.9 for rectangular buildings, loaded area more than 100, so 0.8, and roof subjected to external and internal pressure, so KC 0.9. So substituting all in this equation, the design wind pressure got us 1424.8 Newton per meter squared. It should not be less than 0.7 PZ. So 0.7 into PZ is actually 1539.135. So which is less than that. So we have to consider maximum 0.7 PZ. So the design wind pressure now 1.539 kilonewton per meter square. So this is the difference between the wind pressure calculation as per 1987 and 2015 code. Just you try this simple problem, same like earlier. Here the building width also have given, terrain category you can take. So you just cross check your answer. Thank you.